Okay, it's recording.
Okay. I think that all of you are familiar with Rhino. I heard about some tutorial you had. So I think it's better to start with some details and the whole concept to make sure that we all know some basic and fundamental tips. Because of that, I started from some content or whatever. I hope that you're all come with me and follow me until the end. So for the 3D printing of the train contour modeling in Rhino, we wanna go for making some model like this. In the second sessions, we have a in-person tutorial that you can model some landscape and contour line like this, and we will talk about it more. But for today, we need to know some essential geometric definitions like the edge, surface, points, line, what is solid, what is polysurface, what is the difference between continuous and discrete space, as we I think familiar with the name of mesh in this regard. Yeah, and the most important one is the closed and open mesh. They would make us in a bad trouble if we don't pay attention to this. And we would focus on the intersections and why they are important for us. About the nerves, Rhino logically based on nerves that there are non-uniform curves, as you can see. For example, when you wanna when the Rhino wanna model a car, it tries to create it by the number of curves. So it would be more complicated, or maybe need more time to process or other things. But when you wanna do modeling with the mesh, you try to keep it discrete, and you don't need to do at the same as it's as the real. You just try to simulate the similar one. And you don't need to do it by curves. You need to do it by some surfaces, polygons, or other things. Just try to approaching to the similar shapes. For example, in Rhino, we can have some points, and by connection of the points, we can have the lines, and other different types of line as a curve or polygon. And when we have at least 3 lines, we can have surface. And you can see the different types of surface in the bottom one, the left bottom one. And they would let us to make our modeling. And with the control point that you can see in the right and bottom one, we can easily change the whole surfaces. But when you do it with mesh, you can just control the edges in some parts of the surface, not the whole one. And this one is a good advantage that Rhino give us. Yeah. About the whole process of 3D printing, when we wanna exporting a Rhino model for go and make it with 3D printing, I think we should think about 2 main steps. As you can see the overview here, at the end, we need to export our file at the STL format. STL format is kind of simpler than the whatever we already modeled in Rhino. And so it's the last step, but when we need to check something before that to make sure that our model is printable. It's an important point that we should keep in our mind. And about the STL, it's stands for stereolithography. That it's one types of prototyping machines that change and are modeled to the polygon mesh. So it would be more clear for the machine to print it. If we want to go to the process, at first we can have our object and select it and then export it. But it's not as easy as it seems. We need to check something like closed poly surfaces, meshes, and then go for the import of this. So we can, what should we do and how we can export the Rhino model for our 3D printer file? At the first step, we need to check something that I bring a picture of this for you. We need to check the object. Always we should check the properties of our object to make sure that these are solid. And about the poly surfaces, it means that content of different types of surfaces, and they're all coming together and creating our object. So we can check them easily, but we should pay attention to these 4 shapes. The first and the left one is an example of the closed mesh. When we see something like this, we are good. I'm not sure if you remember the game that you should draw a line without putting off your hand and in just one try. I'm not sure if you guys played or not. It's kind of like that. You should start from one point and come and be able to come back to that one. It's geometrically, it would be kind of like this definition. And for the second circle, as you can see, if I start from one point, I can reach this beginning of the sticker again. So it's not closed, and it's a problem. So we should pay attention to such things, and we go for it at the rest. How should we handle it? But we can see and pay attention to this one. The other one, we will talk about the intersections in the following. And one important thing in the practical steps is about the thickness. Our thickness, the minimum thickness shouldn't be less than the 0.05 inches. We can have the more thickness, but we should pay attention to the time management, and maybe because when 3D printing working, it starts from the first, for example, ground level and put all levels up to it. So it would make it I'm not sure, complicated or maybe melted when it's printing, because it's kind of hard. It's more than 400 degrees. And there is some, they would make some problem, I think. So we should be realistic. And I think when you do it in some example, you will make sure that you are doing good. No worries about it. About this self-intersection, it's one of the problems that may occur when we are modeling. At the left, we can see that 2 different objects intersect. It's good, and it wouldn't make any complicated situation for us. But at the right, as you can see, there's just one object that has the self-intersection. For example, I'm not sure I can write anything. Yeah. For example, when you are starting, you think that you wanna analyze this surface as a 3D printer or a designer. So you start from this one and get to this side, and you change the whole process. If you want to see it as section, maybe you go through the whole different one, and even it's kind of hard for it's kind of rotating in somewhere. I'm not sure that I draw it good or not, but geometrically it would be inside in outside and outside in inside. As complicated as we can see it now, it's more complicated for the 3D printers. So we should pay attention to the whole surfaces that we are make. For example, we should think about the position of these points compared to each other. It's not complicated because when we change the direction or whatever, we can see that, for example, one part of the surface it's bright red and the other one is the dark red. It's kind of thing that we should pay attention to it. It's not a good thing, and it means surf intersections. And you can, most of the time, you can see some errors or some, I think, the windows opening that you are you sure to want to do it or you want to change direction? I think that you guys, if you work with Rhino, you did it, you saw it already. And that's all. And if you have some problem about the self intersection, you can just easily rebuild it, explode it and rebuild it with the command bar. You explode it, and so all these lanes that make problem would be separate, and you can create the new one from the first. You know, these are separate, so wouldn't make any rotate or whatever. So we are good. And can go over. Okay, and about the closed mesh, as I told you, what is the closed mesh? You know, I think the definition of this, but I bring some examples here with the similar shapes that you may see for make sure that you know the concept well. For example, we wanna know that is our shape is or object is closed or not. We can easily go to properties and see the situation of the shapes, and no worries about it. And about the 3D printable shapes, we need to have the polygon mesh. So when we create our surface or maybe create the mesh, at the end, we would go for the polygon mesh, and so that we can see this situation of edges or whatever easily. As you can see here, we have the closed mesh of the main object at the bottom of the page, this page. But in some cases, we don't have any idea, and some parts of the object is not closed. What should we do? What do you think? It's kind of complicated, especially we have many different types of objects. At first, we can look at the model and try to find that. It depends on the geometry that you made. In some cases, it would help. In some cases, not. Especially, you can go for the wireframe view and check if there is some edges. Maybe you just add some edges or create surfaces or cap. Maybe it's work. But most of the time, we need to check more than just by looking around. In that case, we can just easily write show edges in the comment bar. And as you can see at the right, these points shows that there's some problem here and there's no edges between these points. For example, when you want to go from one point to another one, there is no edges that you can go through it. And it means that your mesh is not closed. So you can easily, at first, it's an important part. When you know the problem, you can easily fix it. And when you go for the show edges, you can see the naked edges. That means the open edge, and easily create the one. And that's all. You solve the problem. You can use the, for example, loft, as you can see in the middle part, this triangular that we can use loft, or we have different comments for creating surfaces, for example, with 4 point, with 2 line, different types of surface, creating surface that we had in Rhino, and we can easily fix it. It's not a big deal, just we need to know what is the problem. And at the end, when we finish and done the modeling, we export the STL file, and we don't need the details or whatever, just the binary and a small size would be enough, and we explore as a STL file. And after that, we depending on the types of the 3D printer machine, we should download the software, the related software, and bring our STL files into that. I'll show you what we have in our lab and about the machine. It's kind of straightforward and no worry about it. Just you need to search for the machine and download and import your modeling. This when you get to this level steps, you're good, and kind of it's depending on the machine until then. Yeah. So for I think tutorial, we need to go for some contour lines. I bring some of the pictures here to know the whole concept on contour. When you want to model, you need to think about the goal and object of your modeling. For example, when you want to model some building, landscape, or whatever for presenting it as a rendering or 2D file, it would be kind of different. You may don't need to pay attention to details or maybe some bugs or problem in your modeling. But when you want to make it by machine, you need to check everything. The same approach here. For example, when you see these contour lines and different elevations, you may think about how you should model it. I think it's the main and most important parts of the modeling. I think it's a good approach that when you want to start modeling, just for some minutes, think about how we can do it easily, or how we can do it, because there are different approaches and there is no right or wrong. For example, for the contouring, we can start for the topography line, as we can see at the left and bottom of the slide, or we can start with offsetting and try to fix them related to site, or we should, when we wanna model some contouring, we need to imagine the next step. What should we do for the contour lines, and about the elevation and heights. We can choose one of these examples and do it now together to make sure that you guys get familiar with this one for your next tutorial sessions. We wanna go for some contour line like this, that we already made it, and it's the physical one is in the lab. As you can see, there are different level of elevation lines, elevation control lines that all done by Rhino and modeled with Rhino. And the whole process, I think you are now familiar with it, and just printed by the 3D printer. And we wanna make something like this for the next sessions. So now we can go for this contour lines and how we can create the geometry of it, and then try to solve maybe further problems. Okay, just for now, I wanna make sure that there any problem. I'm not sure I did it. The other one, okay, I need to think what's the problem. This is another example that made by the grasshopper. As you can see, there's a surface on the with different elevations. As you can see, I bring it here because it's like the whole process that would take during the 3D printing, starting from the 0 level, for example, and coming up, and you can see every single lines. And the 3D printer do this all at the same time, and starting from one level and go to upstairs, upper levels. So as you can see, we shouldn't have any hole or other thing. And I'm doing this for this. And for now, we can, for example, start with one of the pictures I've shown you. You can easily bring and import your pictures in the Rhino and start to draw a line on it. For now, I think we can go. Okay, I can drag it. I think it would be easier. I just want to show you the whole concept. You can also do it by drag and drop or whatever. I need to. Sorry, my laptop is making some noise. I hope that it won't crash. These days, not good. Yeah. Try to. Okay, I can go for myself. Maybe it's better. For example, we have this area. I think our area should be 10 to 10 centimeter maximum. We can do it with the real one. And as you can read the command line, you can see that what you want to go for example, is 10 to 10. I think my unit is in centimeter or meter, no worries about the scales. And maybe we have contour line. There is different types of, you can create different types of curve here, as you can see, and you can just put your mouse on this and read the notes here. For example, I always, when I want to go for the contour line, I choose the interpolation one, because the points are on the curve, and maybe it would be more accurate. And when you wanna, now you know the concept of the closed mesh or open mesh, and when you wanna go for creating the line, you can think about the further steps and think about the whole joins and connections between your lines. For example, when I start to do the top of the contour, I'm thinking about the closing now, because in further step, if I don't pay attention to it, it would make some problem for me. And now as you can see, it's closed. And we can easily go to offset and select our curve, and we can, for example, set the distance. I'm not sure. It's kind of like a heart. Okay, maybe I need to change the geometry of this a little. Okay, and then I can, if you want to draw and repeat your recent comment, you just can right click, and as you can see, the offset is here. You don't need to type anything again, and just by clicking, as you can see, even the distance is in the history of Rhino, so I can do it easily just by drag. And but I think that maybe I can go for the yeah, lower distance, and again just click right click, and again have the whole, or maybe in real world we don't need this all with the same distance. For example, when you wanna go do something real, we can do it just by our choice. And for example, but in some cases, maybe you see that when you wanna go for your image, for example, drawing out your image that you exported from your site, maybe there are some contour lines that crossing our area. It's not a problem. We can fix it easily. For example, I try to do something like this. And okay. Now we can easily trim which parts that we don't want. Yeah, as you can see, it says that you need to select the cutting object, and by clicking, we can have the rest that we don't want. And but right click, we close the comment, and we can continue whatever we want to go for. So we have the lines now, so we can create our surface. We can, as you can see, there are different types of different way that you can create your surface. For example, when you have 3 or 4 points, when you have some curves that let you have the planar surface. This one is the network of the curves. It's kind of geometrically, it's kind of it means the mesh, but networks is the vast number of the mesh, you know, as it's kind of complicated. You should pay attention when you work for that one, because it's not NURB or continuous surface anymore, and you should think about this. In some cases, maybe you need this because you don't know the whole curves, the whole edges of your surface, so you have to go for this. But in some cases, like now that we have the whole curves, I think it's not necessary to do this. And as you can, as we talk about it, there is loft here. As you can see, we can, when we have two different curves, we can connect them with the number of curve between these two, and it means the loft. We connect them and create a surface containing a number of much number of the curves. And they have the other one, for example, with edges. The most important, I think, a famous one is these are the kind of golfers, and these are some a specific one. In some cases we can use and go for it. And we also have the other comment here. For now, I go for the planar surface because I already know and see my curves here. And we can go for the perspective one, when you double click on the viewpoint, you can change it easily. I always try to go, when I do modeling, I go for two viewpoints at the same time. For example, for top and front, especially when I wanna go to grasshopper, I should consider the half of my page, the screen for the grasshopper. But for now, we are good. When you do it in two view at the same time, you make sure that you're doing right in 3D phase especially. So for now, we have our curves and we wanna make the surface, so just can easily, at first, as you can see, if I select this one, there would be some problems. You can see now, I wanna show you. You can see there is just curves on a surface. When I select the surface, you can see that the Rhino know the typical one and didn't do anything for these all. Now I can do two works. One of them is I can project the curves on the surface. When you project the curve on the surface, you kind of split it or put it in the surface, especially, for example, you have some curves in the 3-dimensional and you wanna put them, for example, your topographic map on the map. It's kind of the reverse of whatever we have. For example, you have the 3D model and you want your curves of the contour line, as we can see, you can project it. And now we can do it, but I think with Control Z and at first split and then come and change them into the surface, we would be good for now. Edit more, Control Z, okay. I change it to wireframe. Yeah, and we can go for the split. Yeah, and as you can see, select objects, and by clicking the cutting object, can when you want to select more than one object in Rhino, you can hold the shift. So these are, as you can see, there are different parts of, you can see. Okay, now we can go for creating surface. Can start from 1 point, as you can see now. Just by right click and selecting the surface, you don't need to type anything more than it was before. You can see easily, you will have all the parts. And as you go further, it would be easier because it's kind of near to the curve. But because we did offset, you can see that we have more nodes at there. I think that these are not separate, so okay. I can go for this now because I want to continue. I think it too. So now we can go for change it to 3D model with the extrude. And we can have the extrude surface, and we know the elevation or whatever. We can start from the lowest parts if we depend on the information that we have. For example, I start from this part, and I'm not sure about the number. We can try some for now. For example, just by again click right, and you can do it twice or add to the number of this one. Okay. Okay. No worries, I can do it again. I'm not sure what happened. That's good. And just right click. But for now, I should add my whole number so that you know the contour line and elevation, so you can easily go for the next one and adding the distance or okay, this last parts are all together, no worries about it. I just wanna make sure that we do the whole process together. Okay, now we have some basic geometry of the sides, and this kind of simple, and I think that in real world we have more details or complicated curves, even curves, but it depends on the scale of the project. Maybe we want to just go for the one part of the side, so it makes sense. And after that, we can, it's good for now, but we need some more realistic one. We need some soft landscape or surface. So we go for the top, for example. We can see the whole, and there is a drape. It's kind of best friend of the contour line. Kind of it could help us a lot. And as you can see, it says that drag a window over the area to drape. So I drag the window, and as you can see, it's kind of put some surface on my geometry. And as you can see, the spacing is now as a default 5. You can try the number and play with it. It's kind of like a game. And as much as the number is higher, the geometry and the surface would be more accurate. So we would have more elements, and we should consider all of these parameters together. Not too much elements, not an accurate one. So maybe I can see the 5 at here. Maybe I can go for more, for example, 20 as a spacing. And maybe I can try just accept and see it's not enough. Maybe we can do it again. I'm not sure what happened to my. Okay. Not sure what happened. Don't let me to do it, but okay, I think keep this one for now, but you can try more. It's not a big deal. Sorry for the processing. I hope that this will be better. Okay, and after that, we can go for maybe, as you can see, we have two different geometry here. We can again do a splitting to have just one, and we can do it the same process again to have more beautiful and accurate shapes. So now I can go for the split. There are a lot of things that you can do for everything. And when I want to select object, I can select this one. Yep. And the other one, maybe. Regularly, it won't take too long. I need to fix my system because of that. I can do, as you can see, there is some problem because maybe it's about the selecting. We should do it again because now I saw the problem there, but okay, I can do it. Oh, thank you. I can do it again, finally. Great. The split. After this one, when we do the split, it changed to solid because it's the intersection of two surfaces. And if there is any parts that maybe remain or any hole or gap, we can go for the loft and connecting the edges as I showed you here for creating the surfaces. So we would good after this one if you did it. So the same process. And after that, for example, I can show you in my modeling of the sides. I go to the wireframe. You can see that they're all surfaces. As you can see, these are the control and the curve that make the surfaces. And because it's planar one, you just have I keep it simple and I just have to curve, and it's kind of four surface network. Because of that, I thought that you think you need to keep it simple. Or for example, for this stone, I did something like the same we did here. You can model it with different aspects, but I just draw this line, this curve, and this curve, and these whole edges, and after that I connect them with the loft. As you can see, it's surface and shaded now, and there is no hole in this. And after that, for example, we finish the modeling, you can create your geometry directly from this tab. For example, go for some intersections or whatever with solid. It's another way that you can make sure that your mesh are close and you have the solid one. Or you can start modeling, for example, with the cube or rectangular one, And after that, project your lane, your curve on that, and do the whole process from the reverse side. There is no difference, or for example, even you can do it with pyramid, and that would be good. And whenever you have no edges alone, it's good. So for example, you finished your modeling, like as we have here. You need to check at first the thickness and every single parts and element that may be repeated, or maybe even some layers that you imported from another thing. It would maybe help, because and depend on the scale of your project. When you finish this, for example, my site plan and this thickness about the street or whatever, it was, I think, 3 times more than this, and I reduced it because of the further complication that maybe would happen in the 3D printing one. But we should keep in our mind the 0.05 inches, that is the minimum thickness. We shouldn't go less than that one. And keep in mind that 3D printer put the typical and default surface under your foundation. So no worries about the foundation or anything happen or broke or whatever. Think about it, no worries. Even you don't choose anything as a foundation, it has some with your modeling. So try to keep it simple and thick as you can. And for example, now I finished my modeling and I want to go for the 3D printing. You don't need to save your file in different, save your model in different parts, but you should know the dimension of your machine. For example, for our lab, I think it's kind of 20 to 30, but the surface that maybe it works, or it's kind of less than 15. You can know this information in practical phase. You can't just know the whole concept. You should go for the direction and dimension of your the surface of the 3D printer, and divide your site to that pieces. For example, I divided my site, as you can see, 1, 2, 3, 4, 5, 6, and 7 areas, you know. And for every pieces, you don't need to export and make new one. When you wanna export the STL file, you just select with what part that you want. For example, I want this one, and go here. As you can see, there is export selected. When you select this one, it will let you to save it in different types, as you can see, and we should go for the STL one. Where is this? Yeah, this one. As you can see, the same as we talk about it here. I have some for different parts. For example, I label it from left to right. You need to label it clearly when you want to do it with 3D printer. There is a small screen out there you need to you can check, but you need to know the whole concept. I did it, for example, like this. Maybe it's couldn't, maybe some person need more detail. And for example, you write name and just save. And as I told you, you should keep it simple, and it asks from the meters, it's good. And when it goes to the saving, you should choose the binary. It means just 0 and 1, and the minimum number of the edges and the whole elements. And it says that export open object is no worries about it. You maybe need and you check the whole things that we talk about. So just go for the OK. And when you go for your folder, you can see that it's saved right there. I'm not sure where I did save it, but I can Okay, I didn't select anything. I just wanna know that address or whatever. Okay, for example. And after that, you need to know the name of your 3D printer. For example, for our lab, we have MakerBot print. You can easily go to the site and there is a name of the 3D printer on the machine, so you can easily download it and it's free. And you can create an account by your email. There isn't any complicated things here. And this is the surface of our 3D printer. It's kind of the simulation of the machine. There are some options here. The first one, we should go for the file and open the project here. As you can see, it knows the format STL format. Yeah, and I open it. When you open it, now it's in scale because I worked with this one, but maybe you see that it's a kind of small or whatever. When you select it, you can go here and change your scale. For example, we should have the centimeter because of the dimension of our 3D printer and the scale of our work, but you can change it depending on the, for example, you can go for the millimeter, and as you can see, it's kind of like this, and create this and model this with the scale that you want, and you can easily drag your model in what part of the whole surface of the 3D printer. There are more options here. For example, the most important one is okay. After you may, as you can see, there are some things that you can select, like the setting here. When you see something like this, you should go for maybe some error in selections. For example, you should choose a printer that you're working with. I think we don't have connection in the lab, so we can't go for the connected one. We go for the unconnected, and it's the types of the machine that we have. So we select it, and now I don't need to export. Okay, now as you can see, I can select another tabs that are here because these are depending on the machine. And there are some choices here. I suggest you to keep them as a typical one. In some cases, we may need to change it, but I say it due to my experience. And the most important one is that we have 3 types of the printing. As you can see, it's balance, draft, and mini leaf. When you select each of them, you can see the time and the simulation of the whole process. And the main, I think the mean field would take less time compared to the other one. As you can see here, it depending on how it create the model. I can show you some examples. These are not here. Yeah. For example, here we have this cubic network. This is, I think, the draft one that make the foundation and the whole levels. As you can see, there's a hole, and you can see the way that it's printing. And oh, don't have the picture of the another one. And there is a linear one instead of the cubic, printed linear one, and maybe take less time because of the whole process. As you can see here, it's the draft, and then it have more the elements, and this one has less elements, and the balance one. For example, I don't know, and go for the main field and select the done, and select. As you can see, I select the time, and it's for estimating the preview and whatever, and tell me that what happened. If you see that, you can play with it and change the way that it's printing, depending on your case of modeling or whatever. And in some few seconds, it lets us know that, for example, how long it would take. But the real time, it's most of the time less than what it says. I'm not sure what happened. Maybe it's considered the whole space, not the empty one. But at least there is 1 or 2 hours difference in centimeter scales, based on my experience, I tell you. So don't be afraid of this one, but pay attention to consider every unpredictable things. For example, my laptop crashed, or one of the 3D printer didn't work, and they weren't not my fault, but it happened, and we couldn't fix it, and the whole process and time management changed. And you should consider something like this when you do your projects with technological one. Yeah. And I hope that it's tell us. And after that, we chose the way that we want to print. We just save it, export it, and that's all. When we export it, it automatically save it with the format of the format for our machine, and you just copy it in your flash or memory and put it in the 3D printer. There is a spot there. You input your memory adder and just select the printing. We can go for the other one maybe in next sessions to make sure that we know the whole concept, but there's no complicated things. I think it's finished, and as you can see, it says that it would take 20 hours and I think 12 minutes. If I start printing now, it would be finished on 9:26 tomorrow. You can see. I think this one, it's kind of like this, but less than 20 hours. But you can know the whole concept and the time you need, or maybe something happened, and even you can choose the display mode about, for example, if this is the foundation and that I told you is the default one, you can, even you don't choose this, you can see that it's printed with this. Most of the time don't select this one, but it's good, and we don't need the layer highlight. I most of the time go just for the material as a geometry, not a specific material that we do in rendering or other thing. And we can export, and as you can see, the format is MakerBot. For example, I have something like this here. I go for the site, for example, and it's saved with this, and it would take some time, and I can go for the address here and copy it and just input it as a memory, my memory, to the 3D printer. Because it's we don't have connection between the devices out there. We need the memory when we want to go for the printing. Yeah, and that's everything. I'm not sure if any questions.